49 on 2.5. So 49 on page 129. It says if f of x equals x squared plus 10 sine x, show that there is a number c such that f of c equals 1,000. Okay, if you remember, if we go back for a second to my handout from continuity, I thought I pulled it out, but maybe not. Here it is. My handout from continuity. On the back, we said that everything is the same. I just gave you the example with n being specifically 0. Right? So in our case, instead of 0, we have 1,000. So one possibility would be to subtract 1,000 and create a new function. I'm going to call it g of x, which is x squared plus 10 sine x minus 1,000. And show that there is a c such that g of c is 0. So this is the same with this. Now, this is what I would have done. Now, if you want to stick with this, then you will have a little bit more difficulty to find the interval. But we can find the interval for this and then go back and say, okay, now I know where to look for it. So because you will have to solve the inequality f of a, and we have to find the interval, right? We have to find a. F of a less than 1,000 less than f of b. So I have to find a and I have to find b. So the question one more time is asking us, show that there is a number c such that f of c equals 1,000. So I have to say that, so the question is really asking us to show that there exists an interval, like for example, I'm making this up right now, 1 comma 2, or the interval -3 comma -2, and so on and so forth, to show that there is a c in there. Okay, so if you go my route by simply subtracting 1,000 and creating a new function, then showing this is the same with showing that f of c equals 1,000 for this function. But this is much easier. I will have to find an interval. I will have to put this function in the graphing calculator and try to plug in some numbers and see. I know it's continuous, and I will have to write that right away. So 1, g of x is continuous everywhere. We mean -infinity to infinity, for sure. As a addition, subtraction, whatever you want, as a combo of continuous functions everywhere. So now I only have to show that f of a is g. I'm sorry, I named it g. G of a is positive and g of b is negative, or vice versa. So I have to put this in the graphing calculator. So in y equals, clear, I showed something else earlier today. So I have x squared plus 10 sine x. And be very careful. Every time we deal with sine, cosine in calculus, everything has to be in radians. So you have to make sure that in the mode, so minus 1,000. In the mode, make sure that you have radian for degree, for angles, not degree. So then I go back to second table, And of course, this probably this, yeah, this, since they updated here, everything changes back to the default. So I go to second and table, and I start plugging in numbers. So I'm going to plug in, I don't even know where to start, to be honest. I'm going to plug in -2. I'm going to plug in -1. I'm going to plug in 0. I'm going to plug in, so there is a solution already at 0. Okay, I'm going to plug in 2. I'm going to plug in 78. So 78, I'm going to plug in 76. Okay, so I'm going to plug in 10. Okay, I'm going to plug in 11. I'm going to say 20. I'm going to plug in 30. I'm going to plug in 40. Okay. So I know now it's somewhere between 30 and 40, but I have to give an interval that is 1 unit length. And I cannot just give a solution. Okay. Right? I mean, when x is 0, it's at -1,000. So I don't have a solution yet. But I know it's between 30 and 40. I'm going to go with 35. Okay, I'm going to go with 34. So let me go back up because they will disappear. I'm going to go with 31 and 32. That's all I need. It's between 31 and 32. It changes sign. So the interval is between x equals 31 and x equals 32. So A equals 31, B equals 32. G of 31 is negative. G of 32 is positive. Therefore, by IVT, there exists a C in the interval 31, 32, such that G of C is 0. Now, you will say, is the C the same for that? So I created a new function, and I determined the Z for this, for C, the C for this. So if you want to check, you go back to y equals, and I will clear everything, and I will put in, I didn't have to, but it's more difficult with this software. So it's x squared plus 10x, I'm sorry, plus 10 sine x. And now in this second and table, I will plug in 31, and I will plug in 32. And that's my answer. Is there a number between 31 and 32 such that our initial f of x is 1,000? Yes. Because at 31 is 956.96, and at 32 is over 1,000. So because the function is continuous, it has to cross the line of 1,000. If it's coming from 956 and it's going to 1,029, it has to cross the line of 1,000, otherwise it would not be continuous. But I would not even attempt this. I will create a new function subtracting 1,000 and then plugging in this. And then you can go back and check if that's what you want to do. So there must be a C between 31 and 32 that makes the original function in our problem, f of x, makes it be 1,000. So there is a C, and that C is guaranteed to be between 31 and 32. I don't know what it is. The intermediate value theorem does not help us find the number. It only says, look, I guarantee there is a number between 31 and 32, but it does not help us determine it. But it's still a tremendous help, though. because it tells us it must be in there, and that's huge. However, if the function fails to be continuous, the intermediate value theorem is no help at all. So that's the bottom line. Continuous and changes sign, yes, there must be a number in there. But if it's not continuous, even if it changes sign, the intermediate value theorem is no help.
So on an example, we just have to write down 1 and 2 as our
You mean this?
overall work.
Oh, yes, for the intermediate value theorem, yes. The 1 and 2, yes. So for some reason I looked there. Yes, you have to. It's part of, so you have to show the hypothesis, and you have to show the conclusion. And you have 2 hypotheses in there. One is that the function is continuous, and the second one is it changes sign. Can you do it without changing? Yes, you can. But I don't want to look at numbers. I prefer looking at positive and negative. That's why I did this. I created a new function. And then in the table, I was looking at positive and negative. Okay, very good question. Is the other one that Tony was asking, 55, is that the same type of? Okay, it's the same thing. You have to do the same thing. Meaning for 55, you have to put in the calculator, creating a function, set it equal to 0, right? You create the function as we did, and then you have to plug in numbers, but they have to be radians because that has cosine in it. So you have to make sure that if you use your calculator, you plug in numbers and your mode is in radians. Is this good enough for both?
Yeah.
Okay, perfect, excellent. Anything else? Other questions for me? Other questions? Yes, let's look at 21 and 2.6. Let's take a look. Where is it? 2.6. 21. Yes, of course. Limit. And I see x approaches infinity. Am I correct? Okay. And the top is 2x squared plus 1 squared. And the denominator is x minus 1 squared. And x squared plus x. Perfect. What is the degree of the numerator? 4. Very good. The top has degree 4. What is the degree of the denominator? 4. Do we all agree with that? 2x squared squared is x to the 4th. X squared times x squared will be x to the 4th. Both have the same degree. We do know from pre-calculus that when we try to find the horizontal asymptote, and when x approaches infinity, if the top has the same degree with the bottom, the answer is the leading coefficient over the leading coefficient. Let's say we don't remember that. So obviously I expect 4 over 1. 2 squared is 4, 1, 1, so I expect 4. I expect the horizontal asymptote to be 4. But let's prove that from the beginning, okay? So let's suppose I forgot that. So here's what we have to do. Can anyone square the numerator and for us? And let me remind you, we have a contract that we signed on the first day on this. So please tell me what to write.
For x, 4x squared.
Excellent. Thank you. Again, on x minus 1, we have a contract. So please tell me what to write. Excellent. Excellent. Good. So now I have limit as x approaches infinity, 4x to the 4th plus 4x squared plus 1. And we have to FOIL the denominator, sort of FOIL, because I have 3. That's why FOIL is not Correct. So I have two terms here. I'm going to distribute x squared first, and then I'm going to distribute x to all the three terms. X squared times x squared times negative 2x, x squared times 1. Finally, x times x squared, and x times negative 2x, and x times 1. Are you with me so far? Any questions? Just algebra, right? Just multiplying. We didn't do anything yet. Okay, good. Now I have to combine like terms in the denominator. So limit as x approaches infinity, 4x to the fourth plus 4x squared and plus 1. Now I see x to the fourth is by itself, x to the third minus x cubed, and then minus x squared and plus x. Perfect. Like we did last time, what am I going to pull out from the top as well as from the bottom? Exactly. So limit as x approaches infinity, x to the fourth, x to the fourth. The degree, even if they were not the same, I would have factored the degree. So if the top is x to the fourth and the bottom is x to the fifth, I would factor x to the fifth at the bottom and x to the fourth at the top. I factor out the degree. It happens that they both have the same degree. So I need 3 terms here, and I need how many terms here? 4 terms. I'm ready for the terms from the top, for the top. Excellent. That's it. Let's check, make sure that this is correct. X to the fourth times 4 is this. X to the fourth times 4 over x squared is this. And x to the fourth times this is 1. Good. Now I need 3 terms, I'm sorry, forgive me, 4 terms at the bottom. Yes. Yes. Excellent. Excellent. Yes. Excellent. Now please tell me what will be my next step. Exactly. 1 and 1. And now we know a theorem from last time. As x approaches infinity, where does this go? Perfect. Same thing, as x approaches infinity, where does this go? And here, where does this go? And where does this go? And finally, where does this go? So where does this go now? Exactly. 4 over 1. As we expected. That's what we learned in pre-calculus. So if a limit of a function when x approaches infinity is 4, what did we learn last time that this means? So we know now that the limit as x approaches infinity from this function is too much to write. Is this? This implies what? Exactly. Y equals 4. I did not use the fact plus or minus. Therefore, I'm going to say y equals 4 is a horizontal asymptote at both, or just say it's a horizontal asymptote. Very good question. Thank you. Does it make sense? Okay, good. Next problem. Anything else you worked on? Anything else you had difficulties or you just want to ask? Is there anything else? Anything else? I have 4 questions for you. So let's work on this. Again, individual work, open notes, open book. Look at both sides and start with number 3. I recommend. It's up to you. So you have 2 questions on each side. Open notes, open book. I recommend start with number 3.